Welcome to the Explainer. You ever stop and think about what really happens when you hit send? It seems so simple, but today we're going to peel back the curtain and follow the incredible, super fast journey your data takes in that one tiny moment. All right, let's get into it.
I mean, it feels like magic, right? 1 second you're typing, the next, your message is somewhere else. But it's not magic. That single click kicks off an unbelievably complex trip through this hidden world of cables, switches, and routers. And the only reason it works is because there's a super strict set of rules that governs the entire thing, making sure not a single bit gets lost. So, to keep everything from descending into total digital chaos, every single device on a network, I'm talking your phone, your laptop, even the massive servers at Google, they all have to play by the same rules. It's like a universal blueprint for communication. And that blueprint is called the Open Systems Interconnection Model, or, the OSI model for short. It's basically the official rulebook for how data gets from point A to point B. Okay, so this model breaks down the whole journey into 7 layers, 7 steps. When you send something, your data literally travels down this stack, from layer 7 all the way to layer 1. The best way to think about it? Imagine each layer is a different station on an assembly line, and each station has one specific job, to wrap your data up and prepare it for the next leg of its journey. So as our message makes its way down through those layers, it keeps getting wrapped in more and more information at each stop. This whole wrapping process has a name, and it's a big one. Encapsulation. It's absolutely fundamental to how the internet works. So let's follow our message and see exactly how it gets all these digital shipping labels attached. All right, first big stop on our assembly line is layer 4, the transport layer. You can think of this layer as the shipping manager. Its job is to look at your message, and if it's too big to send all at once, which it usually is, it just chops it up into smaller, much more manageable chunks. But here's the really clever part. It doesn't just slice up the data randomly. It numbers every single piece. Why? Well, because on the internet, things can get messy. Pieces might take different routes and arrive out of order. But thanks to these numbers, the computer on the other end knows exactly how to put your message back together perfectly, just the way you sent it. Okay, moving on down to layer 3, the network layer. This is where our message gets its long-distance address. Think of it like the main post office. This is the part that figures out how to get your data from your network to a completely different network, maybe even one on the other side of the planet. So each of those little chunks from layer 4 now gets wrapped in another layer of information, a new header. And this header has the all-important source and destination IP addresses. Once it has that IP address, it's officially called a packet. And that destination IP address? That's the global address that tells the entire internet exactly where this thing needs to end up. Okay, so our packet has its global address, but before it can jet off across the world, it has to figure out how to get out of its own neighborhood first. That's the job of layer 2, the data link layer. This layer is all about the next hop, the very next stop on the journey. It's less like a street address and more like knowing which specific person to hand the letter to in a giant office building. So what happens here? Our packet gets wrapped in, you guessed it, another header. And this one contains the physical hardware addresses, what we call MAC addresses. Think of a MAC address like a serial number that's permanently burned into your device's network card. It's totally unique. And once our packet is wrapped up with this MAC address info, it's now called a frame. The frame is what gets the data to the very next device on your local network, which is probably your Wi-Fi router. Whoa, okay, let's just take a quick breath and recap. We started with our message, it got chopped into segments, those segments got wrapped into packets with IP addresses for the final destination, then those packets got wrapped into frames with MAC addresses for the next hop. It's like a set of Russian nesting dolls. And that whole process, again, is called encapsulation. It's how your data gets dressed for the trip. All right, our data is all wrapped up and ready to go. We finally reached the bottom of the stack, layer 1, the physical layer. This is where the magic really happens, where all that digital information becomes a real physical thing. Our frame is about to be converted into an actual signal that can travel through, well, stuff. The physical layer takes that fully wrapped frame and translates it into a stream of bits, just ones and zeros. But how do you send a 1 or 0? Well, it could be a pulse of electricity down a copper Ethernet cable. It could be a flash of light in a fiber optic cable. Or it could be a radio wave for Wi-Fi. Suddenly, our message isn't just data anymore. It's a physical signal, literally racing through a wire or flying through the air. So now our signal is traveling across a physical network. The actual layout of cables and blinking boxes you might see in an office. That's the physical topology. But the path the data actually takes is determined by the logical topology, the software rules. It's a just because they're close doesn't mean it's a straight line kind of thing. You could have two computers plugged into the same device, but the rules might say their data has to go all the way to a router and back again just to talk to each other. The physical layout and the data's path can be two very different things.
So who or what is directing all this traffic? Well, along this logical path, there are two key players we absolutely have to talk about: the switch and the router. These are the traffic cops of the network, and they each have a very specific, very important job.
Let's start with the switch. A switch is a layer 2 device, which means it's all about the local neighborhood. It looks at that MAC address inside the frame we talked about. It's basically the mailroom sorter for an office building. It knows which desk or computer is which, and it makes sure the frame gets to the right person on the same floor or the same local network. And then you have the router. A router is a layer 3 device. It's not the local mailroom. It's the big regional post office. It couldn't care less about who sits at what desk. It looks at the IP address on the packet, and its whole job is to connect different networks to each other. It's the device that gets your packet out of your local network and onto the great big internet.
So that's really the core difference right there. Let's break it down. A switch operates at layer 2, using MAC addresses to handle traffic inside a single local network. A router, on the other hand, is a layer 3 device. It uses IP addresses to move traffic between different networks. It really is as simple as switch for local, router for long distance.
Okay, let's put it all together and trace that first step. Our data, all nicely wrapped up in a frame, leaves our computer. First, it hits a switch on our local network. The switch looks at the MAC address inside and says, aha, this needs to go to the router. So it forwards the frame right along to that next stop. Now the frame has arrived at the router. The router does something interesting. It unwraps the frame to get to the packet inside. It reads that destination IP address, that global long-distance address, and says, okay, I know where this is going. Then it sends our packet on its way out to the vast internet, where it will be passed from router to router until it reaches its final destination. And here's the crazy part. This entire intricate dance happens in the blink of an eye, billions and billions of times a second all over the world. So next time your Wi-Fi feels slow or a website just won't load, you can bet the problem is a breakdown somewhere in this hidden journey. Understanding this language of encapsulation, switching, and routing, it really is the key to understanding the foundation of our entire connected world.